Okay, so let's have a look at the Leaving Certificate Higher Level Maths Paper 2 for 2019 and question 7. So we have a cattle feeding trough of uniform cross section and 2.5 meters in length. So this is our length here, and this is figure 1. The front of the trough segment ABC, so this is our trough here looking at it head on, so we've got ABC. Is a segment of a circle of radius 90 centimeters. So we have 90 centimeters here, 90 centimeters here, and it's 90 centimeters all the way down along here as well. Now the height of the trough dB is 30 centimeters. So from here to here is 30 centimeters. So from here to here then must be 60 centimeters. Okay, now we're told that OA is equal to OC and also OB, so that's 90 centimeters down along here. OB is perpendicular to AC. Okay, we've got to find AD, the distance from A to D. Give your answer in the form square root B times A, or A times root B, where A and B are both integers. Okay, so let's have a look at this this triangle here. Now we will have something like this, where this is A, this is D, and this is O here. This is a right angled triangle. Now we know that this is 90 centimeters here, we know that this is 60 centimeters here, and we're asked to find AD, this distance here. So this is just a case of using Pythagoras' theorem. So we've got 90 squared is going to be equal to 60 squared plus AD squared. So 90 squared, then I'll just write all this out. So 90 squared is 8,100. 60 squared is 3,600, and we've got AD squared here. Just subtract these two, so 8,100 minus 3,600 is 4,500. That's AD squared. So what we've got to do now is just square root both sides. So get the square root of 4,500, you'll get 30 root 5. That's AD. And that's it. We were just asked to write AD in the form A root B, so we've done that, and both A and B are both integers. That's fine. So we have that finished. So this distance along here then is 30 root 5. Now let's move on to the next section then. Let's just move this up a little bit. So we want to find the angle DOA. Give your answer in radians correct to 2 decimal places. So just make sure your calculator is in radians for calculating this. So we want to find the angle DOA. So really we want to find this angle up here, or this angle here. So let's do that. Just redrawing that triangle, we have A, we have D, O. This is right angle, this is 60 centimeters, this is 30 root 5 centimeters, and this is 90 centimeters here. Now in order to find this angle here, we can use sine, cos, or tan. I think what I'll do is use tan. We'll call it theta, actually. We'll call it just theta. So tan theta here, tan of the angle DOA, is going to be equal to opposite over adjacent, so it's going to be 30 root 5 divided by 60. So theta then is, our angle theta here is just going to be tan inverse 30 root 5 over 60. So when you work that out, you get your angle DOA, because the angle DOA is just going to be equal to 0.84 radians. And that's to 2 decimal places. It's actually 0.84106866706 and so on, but I've rounded it to 2 decimal places there. And that's all we were required to do. So now we have this angle here is 0.84 radians. 0.84 radians. Let me just write that in. So this is 0.84 from here to here. Okay, next question then is find the area of the segment. Find the area of the segment ABC. Give your answer in meters squared, corrected 2 decimal places. So the segment, now remember what a segment is here. They actually say that in the question here. The front of the trough is a segment. So this part here is the segment. This whole area here is a sector. It's a sector of a circle. But the area of the trough here that we're talking about is the segment. So we've got to find the area of this segment here. So what I'm going to do here is find the area of this sector here. Then I'm going to find the area of this triangle here, and I'm going to subtract the 2 areas. So to find the area of the sector first, that's what I'm going to do. So let's have a look at that. So the area of the sector, so we're going to look at the area of the sector, and that is, we'll call the sector OAC, the sector OAC, or you could say OABC if you want to go all the way around here. The area of the sector here is equal to half r squared theta. This is when we are talking about angles in terms of radians, and we're talking about a radian. Measurement of half the angle anyway is 0.84. So we want, remember our area here, or our angle here I should say, is 0.84, so we've got to double that to put into this formula. So if we double that, we'll get 1.68. So the angle here is actually 1.68. So we've got half times the radius is 90. We've got to square that, and we've got 1.68 radians is the angle of the sector. So if we do this, we get 6804, and this is in centimeters now. This is centimeters squared. Let me just double check this on my calculator. So it's 0.5 times 90 squared. Then we've got to multiply that by 1.68, and we get 6804 exactly. Okay, so this is the area of our sector. Now I want to get the area of the triangle. So the area, now I'm going to find the area of this triangle here, OAC. The area of the triangle OAC is going to be half the base times the height. Our height is 60 centimeters, and the base, from here to here, from A to D is 30 root 5. So from A to C is 60 root 5, just double that. So it's going to be half 60 root 5 times 60. So our triangle is OAC. So we want to find the area of the triangle OAC. So it's going to be half times the base times the height. So it's going to be half times, it's 60 root 5. We're doubling the 30 root 5 that we got in part 1. And then our height is 60. So when you do this part here, you get 4024.92235, 92235.9, and again this is centimeters squared. Okay, so all we've got to do now is subtract these two and then convert to meters squared. Now let's take so the area, I'll write down the area of our segment then is just 6804 minus 4024.9225359. So if I subtract those, I'll get 2779.08. Now I've just rounded this a bit here because this is centimeters squared. Remember, the question asks us to give our answer in meters squared. So you've got to convert this centimeter squared to meter squared. Now if you just think about this, if you've got a meter times a meter here, let's say that's 1 meter and this is 1 meter here, this is 100 centimeters here and this is 100 centimeters here. So if we multiply 100 by 100, we get 10,000 centimeters squared. So 1 meter squared here is just 10,000 centimeters squared. So our conversion factor here is 10,000. So what we've got to do here is divide by 10,000. So we've got to move the decimal point to the left here 4 places, 1, 2, 3, 4, and to 2 decimal places it's just 0.28 meters squared. Now the other way of doing this, of course, is just to convert each of your dimensions here to meters initially and then work it out. But anyway, this here is our answer. It's 0.28 meters squared. Okay, let's have a look at part 4 then. Now we've got to find a volume in this case, so the volume of the trough. Give your answer in meters cubed to 2 decimal places. So again, if we look back at our original question here, original diagrams here, we've just found this area here and we found that to be 0.28 meters squared. The length of our trough here is 2.5 meters, so we know this area here is 0.28. So to find the volume of our trough, all we've got to really do is multiply the 0.28, this area here, by 2.5. That'll give us the volume of our trough then. Okay, so let's do that. Now, so we want to find out the volume is going to be equal to 0.28. Got to multiply that by the length of the trough, which is 2.5. So it's 2.5. And when you do that, you get 0.70 meters cubed to 2 decimal places. And that's it. So that's it for part A. Let's have a look at part B then. So let me just move this up a little bit as well. So we have a sand timer in this particular case. We've got a sand timer here. And the sand timer is for games, and each half of the sand timer consists of a hemisphere, a cylinder of height 3.5 centimeters and a cone. So we've got a hemisphere up here, we've got our cylinder here, and we've got a cone here, and the same down on this side. So all parts have a radius 1.25 centimeters. We can see that the radius here is 1.25, so that's going to be the same for the cylinder, it's going to be the same for the cone. The upper half of the timer is full of sand, so it's completely full. Find the volume of sand in the upper half of the timer. Give your answer in cubic centimeters corrected 2 decimal places. Okay, so we've got to find the volume of this shape here. So it's a compound shape, so all we've got to do is find the volume of each individual part and add them. So let's do that. So we have excuse me, we have the volume is going to be equal to, the volume of a hemisphere is going to be, well, the volume of a sphere is 4 over 3 pi r cubed, so our volume is going to be 2 over 3 pi r cubed. Our cylinder here is going to be pi r squared h, and our cone is a third of a cylinder, so it's going to be a third pi r squared h. So this is our formula. We just got to stick in the numbers now. So let's see what we got here. We have 2/3 anyway. Pi is pi, and our radius is 1.25, and we've got to cube that. Okay, let's keep going. We got a pi here again. The radius here again is 1.25, and this time we've got to square it, and our height is 3.5. Okay, next one, we've got a third. We've got pi again. We've got a radius which is 1.25. We've got to square that, and this time our height is 1.5 centimeters. Okay, so we got to do all of this now. If you ignore the pi's here or leave them separately, you get 125 over 96 here, 125 over 96 pi. Here you get 175 over 32 pi, and finally out at the end here you get 25 over 32 pi. Now if we add those up, we get 725 over 96 pi. And what way were we asked to give this answer? Give your answer in cubic centimeters, so everything is in centimeters here, so that's fine, to 2 decimal places. Okay, so to 2 decimal places then we will get 23.73 centimeters cubed. So that's the volume of sand in the upper half of our timer. Okay, so let's do part 2 then. Part 2. Sand flows from the top half of the timer into the bottom half, into the bottom part. As it flows, the top surface in both parts remain level. So it's not very realistic, but that's what happens in this particular case. So the top part is level. So you end up with a smaller cone here, smaller shaded cone here. Now, at a certain time, 98% of the sand has flowed into the bottom half of the timer. So 98% of this volume up here, 23.73, 98% of that has flown into the bottom part of our timer. So that means 2% is left in the top here. Find H, the height of the remaining sand in the conical part of the top of the timer. Give your answer in centimeters corrected 2 decimal places. So we've got to find the height of this sand here. Okay, so what we've got to do here is get 2% of this volume here, 23.73. So of 23.73. So you've got to multiply this by 0.02. When you do that, you get 0.4746, 0.4746, and this is centimeters cubed. So that's the volume remaining in the top part of the timer, the volume of sand remaining. Now, what I'm going to do next here is just have a look at this diagram here. If you notice with cones here, in this particular case anyway, you have really what you've got here are 2 similar triangles. You've got a triangle inside a bigger triangle here, and in this particular case you know from your theorems that these 2 triangles are going to be similar, so sides are in proportion here. So what I'm going to do here is we've got this kind of shape here. We've got 2 triangles like this. Now because they say the sand remains level, this here is going to be parallel to this side here. This is 1.25 centimeters. This is, we're calling this or centimeters. This is H from here to here, and we know that the height, overall height here is 1.5 from here to here in centimeters. So what we can do here is write down an equation like this. We can say this side over or, so 1.25 over or is going to be equal to, now remember we started with the big triangle, this side and the big triangle divided by this side, its corresponding side in the smaller triangle, is going to be equal to this side in the big triangle, which is 1.5, divided by its corresponding side in the smaller triangle over h. So now we can write h in terms of or in terms of h. Because we have to find h, I'm going to write or in terms of h. So we just cross multiply here. I mean, we're going to get 1.5 times or is equal to 1.25 times h. Now if I write or in terms of h, that will just give me or is equal to 5/6 h. So I'm going to use this in a few minutes. Right, so we have to find the height of this h here. We got to find the height of this sand here, this part here. So we know that that is a cone. The sand is in the shape of a cone. So the volume remaining is a cone. So that's going to be equal to 1/3 pi r squared h. Now we know that that's going to be equal to this here, 0.4746. Now we want to find h, but if you look at this equation here, we have a h here and we have an or here. So we have two unknowns in here. I don't want this or here. That's the reason that I got or in terms of h over here. So now instead of or, I can write in 5/6 h. So I can write in 1/3 times pi times 5/6 h, which we got a square. This is or. So this is this part here, times h is equal to 0.4746. Now all I've got to do now is just solve for h, because I've only got h's now. I got rid of this or here. Okay, so if I multiply all this out on the left hand side, I multiply out the numbers first. The third times pi times this 5/6, remember, is squared. So you got to square that. Multiply it by pi, multiply it by 1/3, and you will get 0.72722 0.5217. Okay, now the h here is squared and it's multiplied by this h, so it's h cubed. On the right hand side you've got 0.4746. So really all I've got to do now is divide both sides by this number here, and that will give me on the right hand side 0.6526 2184 69. And finally then we just cube root both sides. Now we have to give our answer to, let me see how many decimal places, 2 decimal places again, and everything is in centimeters. So to 2 decimal places, when you cube root this, you get 0.87 centimeters. So our height here is 0.87 centimeters. And that's it for this particular question.